Alright, imagine a material harder than most and is able to handle extreme heat and electricity with incredible efficiency. This isn't science fiction. It's called silicon carbide, and it's a secret engine powering the EV revolution, our renewable energy grids and 5G networks. Control this material and you control a critical piece of our technological future. Right now, three global powers, the United States, China, and the European Union, are locked in a high-stakes race to dominate the silicon carbide industry. But each is running a very different race, with different rules, different advantages, and very different strategies for winning. So let's talk about these three superpowers and who will win at the end of the day. Let's start with the United States. America's game plans, fueled by the CHIPS and Science Act, is clear. Protect what you have and build an unsaleable lead in innovation. Think of it as building a technological fortress. This isn't just about giving money to companies like Wolfspeed and Coherent, it is about putting up walls. Strict rules block these companies sharing their most advanced technology through joint ventures or partnership with Chinese firms. The goal is nothing less than American ownership of the entire high-value supply chain, from designing the furnaces that grows the crystal, to slicing them into wafers, to designing the final chip. This focus on cutting-edge technology allows US equipment manufacturers to command premium prices globally. But this Fortress America strategy comes with a real cost. First, the financial cost. Building a state-of-the-art fabrication plant, or a fab, in the US is estimated to be 30 to 40% more expensive than building the same fab in Asia, and that is due to the higher construction and labor cost. Second, there is a market cost as well. By decoupling China, US companies are voluntarily stepping away from the world's largest and fastest growing market for EVs, the very product that needs silicon carbide chips the most. The risk is creating a brilliant but isolated ecosystem that struggles to achieve the scale needed for long-term dominance. Now, let's cross the Atlantic to Europe. The EU strategy was never about building walls, but building bridges between its 27 member states. The mission, outlined in the European Chips Act, is strategic autonomy. In simple terms, they never want to be caught relying on others for critical technology again, as they were during the recent chip shortage. Europe has powerful aces in the hole. World-class chip companies with strong roots in silicon carbide. They also boast brilliant research institutions. Europe's core challenge is its own structure. It must coordinate fragmented landscape of nation, companies, and research labs, getting them to agree on how to share the work, the cost, and eventually the benefits. This is a monumental political and logistic task. The on-the-ground reality is tough. To build the industry from the ground up, European projects are paying top dollar for imported equipment and fighting a brain drain, struggling to keep and attract specialized engineers needed to run these complex operations. The result is that production yield often lags behind more experienced competitors. Europe's bet is that massive funding and united front can overcome these disadvantages and create a self-sufficient European champion, but it's a high-risk and high-cost gamble. Finally, we have China, which is playing a completely different game. If the US is building a fortress and the EU is building an alliance, China is activating a volcano, erupting with massive volume that floods the global market. Their strategy is deeply integrated with the national goal to lead in electric vehicles. While the West debates subsidy packages, Chinese provinces are funding dozens of new silicon carbide fabs. This has triggered an aggressive price war. The price of standard 6-inch silicon carbide wafer has collapsed, falling from over $1,000 to well under a few hundreds in just a few years. So how is this sustainable? Because for China, this isn't about quarterly profits. It's about long-term strategy of market capture. Factories are supported by state-backed banks with seemingly infinite patience. They can operate at a loss selling below cost to gain market share, drive international competitors out of business, and crucially, give their engineers the real-world practice needed to improve their skills and yield. The risk for China is a shakeout. The explosion of capacity may lead to wasted investment and failed companies. But for Beijing's perspective, you only need a few national champions to survive and eventually dominate the global market. So the interesting part is, how does this race look under the microscope? It all starts with the raw material. While often called a rare earth, the key material for silicon carbide is actually high purity graphite. Here, China holds a very powerful card, controlling a significant portion of the global supply chain for this critical input. This highlights a crucial paradox. Despite the talks of decoupling, the world remains deeply interconnected. The West still relies on China for materials, while China still relies on the tools and expertise from the US and Europe to advance its own technology. And this creates a tense standoff. So the future winners won't necessarily be the ones with the most money or the most factories. It would likely be the player that best masters its weaknesses while leveraging its unique strength. Can the US turn its innovation lead into cost-effective scale? Can Europe turn its political unity into industrial powerhouse? And can China turn its massive volume into high-quality, trusted technology? The race for silicon carbide is a marathon, not a sprint, and we've only just seen the first few miles. And finally, the decisions made in Washington, Brussels, and Beijing today will reshape the global tech, influence what cars we drive, and determine how our power grids function tomorrow. This is more than a trade war. It's a contest of systems, and the outcome will affect us all.